Calorimetry Food Lab.
I will build a great wall.
The purpose of this lab is to practice the method of calorimetry and to experiment with this method using common food items. Do not touch the burnt Cheeto ever. Make sure that it has extinguished before disposal. Allow burnt Cheeto to rest on foil. Remember, safety is #1 priority. Materials in this lab include a Cheeto puff, an electronic scale, a tin can, a pencil, a paper clip, tap water, a thermometer, a lighter, a graduated cylinder, aluminum foil, aprons, goggles, a pencil to write with, and finally, a stand to hold the thermometer and a can. The first step would be to measure the Cheeto. Record this in the data table. The next step is to fill an aluminum can with 88 milliliters of water. You can place this aside for now. The third step is to place the Cheeto on a bent paper clip so that it is able to stand freely. The fourth step is to place the can in the holder using a #2 pencil. The aluminum foil should be placed below as a base for the paper clip and Cheeto combination. It should be approximately 1 centimeter from below the can. The fifth step is where the fun begins. Light the Cheeto on fire with caution. Make sure that the Cheeto continues to stay lit throughout the process. Keep your hands and face away from the area. Also, the can will start to heat up, so avoid touching it to prevent burns. Make sure that the Cheeto burns all the way to achieve the best results in the data. Measure the temperature of the water in the can in degrees Celsius. Record this in the data table. The final step is the cleanup. To clean up the station, the Cheeto must be all the way extinguished. After that has been achieved, the Cheeto can be thrown in the trash and disposed of for good. The water from the can can be dumped in the sink. Make sure that the can is cool enough to hold before pouring it out.
Flavortown!
The goal of this experiment is to experimentally find the heat content present in a Cheeto and compare it to the literature value of the heat content stated in the nutrition facts. The equations we use are Q equals MCAT, and also this equation to directly find the heat content. M being the mass, C being the specific heat, and T being the change in temperature. Since we can't directly find the heat content of the Cheeto, we have to use this through water to find the heat content of the Cheeto, because all the heat lost by the Cheeto is gained by the water. The mass of the Cheeto was 2.193 grams, and the mass of water was 88 grams. The initial water temperature was 21 degrees Celsius, and the final water temperature was 50 degrees Celsius. So we plug these into the equation right here, Q equals MCAT, and we find the calories of heat released. And then we need to find the calories per gram. So after we find the calories, which is big C calories, 2.55, you divide that by the grams present in the Cheeto that we originally found right here, and we get the 1.16 calories per gram experimentally found. Then, after we do that, we compare it to the literature value stated in the nutrition facts, and it was 160 calories and 28 grams. So after dividing that, you get 5.71 calories per gram, and it is clear that there is a difference here. So in the percent air, there is a 79.7% air. And then this was trial 1. In trial 2, here's the mass of the Cheeto, the water, and the temperature. And after plugging all these in right here, we got a higher calorie count at 3.29 calories. And then dividing that by the grams of Cheeto present in the start, it's 1.56 calories per gram experimental. Right here, it's 1.56 calories per gram experimentally found. And then comparing that to the same nutritional facts, it is a bit closer. And after doing the percent error, it is 72.7%.
This is the error analysis for our experiment. Our first error is having heat loss to the air surroundings, therefore not having an accurate heat content. As you can see in the picture, there's a thing called a calorimeter. This is what scientists use. This does not allow heat to go out to the environment but stay in. In our experiment, we did not have a calorimeter, so therefore some heat was able to go out to the air surroundings. Our second possible error is the distribution of temperature in the water. We did not have a proper stirring tool to distribute the heat between the water. The water would not have equal temperatures. Some of the water may be hot and some of the water may be cold because of the lack of a proper stirring tool. This would throw off the water temperature measurement. As you can see in this picture, there is a stirring tool, properly distributing the temperatures in the water, making it fairly equal around all the water molecules. In the second picture to the right, there is no stirring tool, therefore there may be various temperatures throughout in the water.